Hi students, Mr. Epperson here. This is a video on how to go from grams to moles to grams in a particular problem. So we'll get started with this particular equation and this problem where you've got hydrogen and oxygen forming here, H2 and O2, forming from basically electricity going through water and splitting water into hydrogen and oxygen gas. The question is asking how much oxygen is produced, how much oxygen gas is produced from 50 grams of starting material. In this case, because it's a decomposition reaction, the starting material is the reactant. It is just, there's only one of them, and it's water. So if I start off with 50 grams of water, how much oxygen will I produce in grams? These types of questions always kind of throw students off at first, but you can do it because if you follow a particular step-by-step process and just calm down and kind of think through it. So the first thing we want to do is to look at what is being asked of us. I always want to look for a couple key things. One, I want to look for a number in these types of questions. So I've got a number here, and then I want to look at the unit. I've got the unit right there in grams, and I want to look at the chemical. The chemical's right there, chemical. So the number, the unit, and the chemical is going to tell me a little bit about what am I trying to do in this problem. I'm going from that starting value, and that's because I was given that number, that's where I'm going to start. So that's how my problem is going to lead off, with 50 grams of water. Now, what am I trying to do here? I'm trying to understand how much oxygen is produced, and I didn't really write it in the problem, but in grams, how much oxygen is produced in grams. So I'm trying to get to grams of oxygen eventually. That's like my goal. But they don't tell me how many grams. That's the whole point of the problem, is to figure out how many grams are produced. So I'm going to go through a series of steps in order to convert from grams of water to grams of oxygen. When you go from grams of one substance to grams of another substance, it should be clear that, one of the main things is that you start off with 50 grams here, then there have to be 50 grams on this side. Conservation of mass tells us that if we react all that stuff, then it will basically turn into 50 grams of something else on the other side. But how much of that is oxygen? How much of that is hydrogen? The whole point of finding molar mass is to be able to do this type of prediction. So we're going to do a molar mass conversion in order to get from 50 grams of water to grams of the substance I'm trying to get to, which is oxygen. So first I'm going to go from grams of water to moles of water. So molar mass of water, I always have 1 mole of whatever substance I'm dealing with in comparison to the weight of it. But the molar mass of water is 18.02 grams. And you can either look that up or calculate it. It's pretty easy. 16 grams from oxygen and 2.02 grams from hydrogen. So that's the conversion from grams to moles. I've cross-canceled my values there, and now I'm in moles of water. Well, why is that good? Once I get from moles, or from grams to moles of a substance, now I can use the equation to sort of jump between different types of substances in that equation. So I can go from this value here at the front, the 2 moles of water, to either the 2 moles of hydrogen or the 1 mole of oxygen. Let's just also, we'll put this in here. There's a 1 right here because if it's blank, you know that the value has to be 1. So I can jump from any of, once I'm in moles units, I can jump from any of the chemicals to another chemical and do a conversion just by using what's called the mole ratio. So how do I do that? Well, first I'm going to look at the equation. I look to see how many moles of water are required compared to the moles of oxygen that are produced. And then I use that molar ratio to convert. So first, I got moles of water down here. I'm going to definitely put that on the bottom so that I can cross-cancel those. And I'm trying to get to moles of oxygen, so I'll put that on the top. And now I just need to look at the equation to get my values. So 1 mole of oxygen on top and 2 moles of water on the bottom. And I cross-cancel my moles of water. And I'm almost there, because now I'm in moles of oxygen. So now it tells me basically this conversion is going from grams of water to moles of water, and then from moles of water to moles of oxygen. And the final step, though, is for me to convert from moles of oxygen to the grams of oxygen that I'm trying to get to. So now I've got my conversion factor for moles of oxygen by using molar mass. So this is a tricky one, even though it's a pretty simple concept, right? Molar mass, 1 mole of O2. What do I put on top? If you look at the periodic table, there's oxygen as an element, right? And it's element number 8, and it's got a molar mass of 16.0. But because O2 has two elements, two atoms of oxygen in it, 2 of them bonded together, I have to actually multiply that number by 2. So the answer to the molar mass of oxygen gas is actually 32 grams per mole. So 32 grams of oxygen. I now cross cancel my values again. And now I just have to do some math. So this math kind of looks scary, but remember, you multiply the top and then you divide the bottom, and you can just do it in sections. So the way that I'm going to do this, I'm just going to use my little calculator built into the computer here and do it over on this side of the screen here. 50 grams times 32 grams. I don't need to worry about the ones because they don't do anything. So 50 times 32, 1600, and then I just want to divide by anything on the bottom. So I want to divide by 18.02. I see that down there. And then I want to divide by the 2 as well. So divide by 2. I get 44.395. Because I started off with 3 measured units, I'm going to end with 3 measured units. So 44.4, I'm going to round to that last place there, 44.4 grams. So my answer is 44.4 grams of oxygen are produced from a reaction where I started off with 50 grams of water and reacted them, and how much is produced? It's 44 grams of oxygen. This actually makes total sense too, because it can't be more. The numbers can't be more than the value I started with. We'd be creating matter there, and it should be pretty close to the original value because hydrogen just weighs so little. Hydrogen is the lightest element on the periodic table, so it shouldn't contribute much to the 50 grams that we have here. 44.4, as we just calculated, is coming from the oxygen, and we could actually just do a little bit of subtraction there and say 50 minus 44.4 is 5.6, and that would tell us actually how many grams of hydrogen are being produced as well, just by using a little bit of logic and subtraction there. So that's how you would do that kind of a problem. I know that looks rather big and crazy, but we're just doing steps of unit conversions in order to put all that together and go from grams that we start with to grams that we finish with. Let's look at a different problem and see if it can kind of sink in a little bit more once we do that. Okay, ethane gas, that's this guy right here, the C2H6, reacts with oxygen to form carbon dioxide and water. Okay, how much O2, again, we're looking at the production of O2. Oh, no, sorry, that's a typo. How much CO2, that's what I want, is produced from 30 grams of ethane. So again, I want to start off with that first thing where I go, where's my number? Here's my number, okay? Here's my unit, and here's my chemical. That helps me because that roots me down where I'm trying to get started. Because there's a lot of stuff going on. It can get really confusing and a little overwhelming at first. So I'll just go ahead and write down 30.0 grams of that chemical here, C2H6 ethane. Now I'm going to convert from ethane to moles of ethane. Grams of ethane, excuse me, to moles of ethane. So the first step is to do molar mass conversion. So I'm going to go 1 mole of ethane, and then go get the molar mass, 30.08 grams. Okay, so now I just convert from grams to moles. Now I want to go from moles of this substance to moles of my target substance, which is carbon dioxide. So I look at my equation, and I don't have to care about any of these things. I just want to focus on the 2 that matter. And I'm going to look at their coefficients. So 2 moles, I'm looking at, I want to put let's actually do it this way. Moles of C2H6, I'm going to put down here because I want to cross cancel that. And then I've got moles of CO2 at the top. And then I just look at the number, which is 2, and I look at the number here, which is 4, and I can do the math on that to go from moles of ethane to moles of CO2. Final step is to multiply by the molar mass of carbon dioxide. So 1 mole of CO2. Now I'm out of moles, and the molar mass is 44.01 grams of CO2. And now I can cross-cancel again. And I'm in grams of CO2. How much CO2? Again, this should have said grams. In grams. But now I just have some math to do. So we'll go ahead and do the math. 30 times anything on the top. There's a 4 on the top. Times, there's the 44s on the top. 44.01. Okay. 5,281.2. Divide by anything on the bottom. So 30.08. And then divide by the 2 that's on the bottom as well. And of course, I'm ignoring any 1s. There's my answer. So 87.8. 87.8. I'm going to round to that 10th place right there. 87.8 grams of CO2 produced. Now remember, in this case, I can start off with I can end with a number that was greater than the number it gave me as a reactant, because I'm also reacting a ton of oxygen as well, which oxygen has like a molar mass of 36, and there's 7 of them. So there's a bunch of mass going into this and a bunch of mass coming out. So this is an okay value. So I hope that was a nice little tutorial on how to go from grams of one substance to grams of another substance by using molar mass and by using mole ratios. All you got to do is string them together and cancel units, and just remember that key step is what are you starting with, and really where are you trying to go. Writing those numbers down, looking at what units you're in, what number of those units you've got, and what chemical you have. I hope that was helpful.